creates an electric field in the space around it. Electric field is a region where an electric charge will feel an electric field. According to Michael Faraday, an electrical field extends outward from every charge and permeates all of space. If a second charge is placed near a first charge, it will feel a force exerted by the electric field that is there. So supposing natay charge here, this is Q sub 1 for example. So around it, no, create na siya electric field. Okay, around it, dili dapitan, create na siya electric field. Na siya electric field din. Such that if we're going to place a force here, place another charge here, Q, this charge will experience a force exerted by this field nga naa dinha. Okay, the electric field in which the variable that we're going to use for that field is E at a certain point is equal to the electric force per unit charge experienced by a charge at that point. So E is equal to F over Q sub O, or simply equal to KQ over R squared. So for example, kani siya si Q1. Kanya namtoy field no around it. There is a field. Tahay dire ani. This is the field and 1. And then we put a test charge here, Q sub O. This is a test charge. So, diba, the force, no? The force experienced by this test charge Q sub O is kaning F sub O. And what is this F sub O equal to? Diba, that is the force between Q1 and Q sub O. So, this F sub O is equal to K Q1 QO over R squared, diba? That's our formula. Divided by kaning Q sub O, in which na-cancel lang sad na to ang Q sub O. So, that's K Q1 over R squared. So, kaning Q1 here, this is the charge present. Okay? So, electric field lines are always directed away from positive charges and towards negative charges. So if this is our Q nga positive, away from the positive, directed towards the negative. So let's solve problem number 5. 2-point charges, Q1, 16 microcoulombs, and Q2, 4 microcoulombs, are separated in a vacuum by a distance of 3 meters. Find the spot on the line between the charges where the net electric field is 0. Problem number 5. Okay, so na ako na si Q1 and Q2. So Q1 is positive 16 microcoulombs and Q2 is positive 4 microcoulombs. And they are separated by a distance of 3 meters. So we are to find a spot on the line between the charges where the net electric field is 0. Supposing that this is the spot here. So we are expecting that the net electric field here is 0, meaning ang E positive man eh, so away. So this is electric field experienced by 1, and this is the electric field experienced by 2. And so the net electric field kay 0 man, so meaning ang E na na-experience nito plus ang E na ni-experience ni 1 or minus rather is equal to 0. So meaning the electric field experienced by that point by both 2 and 1 are equal. So E is equal to KQ over R squared. So E2 is KQ2 over R sub 2 squared. And then here we have KQ sub 1 over R sub 1 squared. So we don't know, kay kani man siya ang point. This is the spot here where 0, and this is a total of 3 meters. So if we let the distance from this point, let's say this is point P. So if we let the distance from point P to Q2 as, say for example, D, then the distance from Q1 to point P would be 3 minus D, right? So we can substitute that now in our formula. We can cancel out K, and then Q sub 2 is 4 times 10 to the negative 6 coulombs, and that distance R to the point P is D squared. Q1 is 16 times 10 to the negative 6 coulombs, and the distance to point P is 3 minus D squared. So 4 times 10 to the negative 6 coulombs times 3 minus D squared is equal to 16 times 10 to the negative 6 coulombs times D squared. So expanding that, 4 times 10 to the negative 6 coulombs times 9 minus 6D plus D squared equals 16 times 10 to the negative 6 coulombs D squared. By the way, you can just cancel out coulombs, no? Cancel naman ang units. Let's just write that again. So 4 times 10 to the negative 6. Okay, and this is 6 times 10 to the negative 6. D squared. D squared. So just to show. So 4 exponent negative 6 times 9 equals 3.6 times 10 to the negative 5 minus 2.4 times 10 to the negative 5D plus 4 times 10 to the negative 6 D squared equals 16 times 10 to the negative 6 D squared. So we can rearrange this and then subtract. No, we'll transfer the 16 to the left side. So 4 exponent negative 6 minus 16 exponent negative 6 equals negative 1.2 times 10 to the negative 5D squared minus 2.4 times 10 to the negative 5D plus 3.6 times 10 to the negative 5 equals 0. So, nag-quadratic ta equation. If you don't want the negative sign first, then you can reverse the signs. So, 1.2 times 10 to the negative 5D squared plus 2.4 times 10 to the negative 5D minus 3.6 times 10 to the negative 5 equals 0. So, mode, equation, quadratic 3. So, 1.2 exponent negative 5. 2.4 exponent negative 5, and we have negative 3.6 3.6 exponent negative 5. Okay, so D is equal to 1 and D is equal to negative 3. So wala may negative din na, no? So meaning this is extraneous. So our answer D is equal to 1, which means that D is 1 meter away, or the point, no, on the field between the spot on the line between the two charges where the net electric field is 0 is 1 meter away from Q2 and 2 meters away from Q1. The spot on the line between the charges where the net electric field is 0 is 1 meter away from Q2 and 2 meters away from Q1.